Did learn this yesterday. Just quickly go through this. So we want to find the distance between the 2 points. Now we could go to the trouble of making an XY chart, plotting the points, but we're just trying to find the distance between them. So we don't need to necessarily graph them. We could. That wouldn't be incorrect. But we want to find the distance. And we know the distance formula. That's something you need to have memorized. The distance between 2 points. So tell me, what is the distance formula?
X1 minus.
Okay, so okay, I always touch that with my shoulder. Sorry, just a sec. Okay, so you said the square root of what?
X2
X2
minus X1
minus X1
squared
plus
Y2
Y2.
minus Y1 squared.
Okay, awesome. Now I think what threw people off yesterday was that they're like, well, those little mini 2's and 1's are giving me problems. I don't know what those mean. What the heck is that? But don't look so deep at it, guys. We have these 2 points, -4, -3. And we have this point, -2, 4. So this is just an XY point. So I'm just going to make note of that. This is just an XY point. One of them is my first point, one is my second point. Does it matter? Does the distance from, does the distance from here to here, is that any different than from here to here? No, so it doesn't matter which one comes first. I'm just going to randomly say, I'm going to call this my first point. I'm just going to put a little mini 1. We're not going to look too deep into it. I'm just putting a mini 1 there to say that's what I'm going to call my first point. So notice, guys, -4 is X1. -3 is Y1. Then I'm going to go to my second point. I'm going to put a little 2. And so really I'm just saying this is my second point. It doesn't mean anything deep. I just mean that this is my second X point. This is my second Y point. Then we plug it into the formula. All right, so I'm going to draw out my square root and show all my work. What is X2?
4. -4.
What is X2?
-2.
-2. So we have -2 minus, what is X1?
-4.
-4 minus -4. How many of you did not make the error of mixing up the minus and negative? How many of you did that part correct? A couple, many. Okay, awesome. Squared plus, what's Y2?
4.
You gotta look at the right place. You gotta stay consistent. It's 4 minus Y1, which is
-3.
-3 squared. I'm gonna simplify that. So I have the square root of -2 minus -4. What happens when we subtract a negative?
Cross the line, change the sign.
Cross the line, change the sign, it becomes positive. So that's actually -2 plus 4, which is?
2.
So we have 2 squared plus, another minus and negative. What happens? Cross the line, change the sign. What does it become?
7.
So we have 7 squared. I'm showing all my work. I'm going to come over here. I'm sick of bending clear down there. So we have the square root of 2 squared.
4.
How'd you get that?
2 times 2.
2 times 2. Thank you. So, I was going to write 2 times 2, but I'm not going to do that. I didn't mean to. All right, you're right. It's 4. Thank you, Justin. Okay, 4. And then what is 7 squared?
49.
49. Okay, well, we can add those 2 things up at this point.
53.
What is the square root of 53? This is where on your graphing calculator, you'll type in the square root of 53. What does that equal to?
It's like 7.28. Goes on.
7.28. What if we round? Are we going to round? What'd you get? Type it in for me, sir.
I got 7.28.
7.28. Did it go further?
7.28010988.
Okay, perfect. So if we round to the nearest hundreds, that would be 7.28. Okay, you were right. Thank you, everyone. You were awesome. Did anybody have any questions? Okay. We'll see more distance problems later on in the year and so on. We'll keep practicing these, but just remember the distance formula. It's not too bad as long as you're careful when plugging in. Go ahead and pass those in. As you pass those in, were any of you able, I'm just curious, were any of you able to watch my video lesson last night if anyone was interested? Awesome. Did you find it helpful at all?
Yeah,
It was helpful. Okay, good. Just keep in mind those are there. I'm having problems getting them to upload from this Mac. I'm trying to figure it out. But I'm glad you were able to view them. Okay, I'll come pick them up over here in a second. We have no time to waste, so I'm going to move on. Okay, so we're going to start off with these, but you should already know how to do these. You actually should have practiced them many times in secondary 1. The only reason I'm going to go over them is because they were on the worksheet or in the book that we were going to do them yesterday. We didn't get to them, and I didn't want to just throw them at you and say, you know what, figure it out. Like, if you don't know how to do it, figure it out. So I want to quickly go over this. Okay, so you should already know how to do this. This is a review problem, but I just want to quickly go over this. So we're going to be solving for x. Okay, guys, we're going to be solving for x. Now, with this, we're going to be using cross multiplication, but I'm going to tell you why. So looking at this, does everybody see how on the left side of the equation here, I have a fraction?
Yes.
Okay, this is super important, so pay attention to this. And on the right, I have a fraction, right?
Yes.
So on the left, I have a fraction. On the right, I have a fraction. Now, if you have a fraction on the left and a fraction on the right, and you're trying to solve for x, you can use cross multiplication to solve. Now, it's really important you understand, though, you would not go through the same process. You could not use cross multiplication if I did something like this. Let's say I changed the problem, and I went like this and added a 2. Now, you might say in the future, and I don't want you to, that's why I'm clarifying, you might say, well, Ms. Christensen, you said on the left, if there was a fraction, and on the right there was a fraction, you could just cross multiply. No, that's only true if you don't have anything else added or subtracted to it. Does that make sense? Simple fraction, yay, I can cross multiply. Okay, so how cross multiplication works, guys, is what we're trying to do is solve for x. So ultimately, we're trying to solve for x. So piece by piece, we're trying to get x all by itself. And no one likes to deal with fractions, so cross multiplication allows us to get rid of fractions. Now on this first one, I'm going to show all my work so that you understand what's going on. We're going to be doing lots of solving for x problems, and every single one takes a lot of algebra and careful doing. So I'm going to show you all my work on this one, and then the next one I won't have to show so much work. But you have to understand what's going on here. So everybody listen up. I have some fractions. So with cross multiplication, you can eliminate, get rid of the fractions if you multiply both sides by what's in the denominator. So let's start with this side on the right. What's in the denominator, meaning bottom of my fraction? 25. So what if I just went and I multiplied both sides by 25? Now it's super important that you multiply both sides by the same exact thing. Now the reason we can do this, guys, is because we are not changing the problem. I mean, we're kind of changing it, but we're changing it exactly the same. So does it make sense you have to multiply both sides by 25? Okay, so it didn't change anything. We manipulated it a little bit, but we didn't change anything. So the reason we did that, let's look on the right. Focus on the right for me. Looking over here on the right, we now have 25 divided by 25. What happens with that? It becomes what?
0.
Wait. What's 2 divided by 2?
1.
1. So what's 25 divided by 25?
1.
1. Anything divided by itself is 1. So really that just goes away. Does that make sense? Do we have a fraction anymore? No, we just have a 10. That's awesome. Let's do it to this side. I'm going to show my work. So right now I have 25 times x over 10. And then I have is equal to 10. Does everybody see how now I don't have a fraction? Yay. Well, I have a fraction over here. What should we multiply both sides by? What should we manipulate this with so that we don't have to deal with fractions?
Times it by 10.
We can't divide it by 10. This is already divided by 10.
Times by 10.
Good, we're going to multiply both sides by 10. Now we can do that because we didn't change anything because we're multiplying both sides by 10. So now I want you to look over here on the left. What's 10 divided by 10?
1.
1. Yay! It's all gone. So over here, all we have is 25 times x, or 25x. Same thing. Now on the right, we have 10 times 10, which is
100.
100. And our last step, well, let me stop there. I get way excited about that. Everybody okay up to there? Are you sure? If you have any questions, I can clarify. You're all okay. Now, ultimately, what we were trying to do is solve for x. We're trying to get x alone. Once we've done that, we've achieved our goal. What's my last step to do to get my x alone?
Divide by 25.
Good, and I have to make sure I divide both sides by 25 or I change things, but since I'm doing it to both sides, I'm all good. The 25 is gone. We have x is equal to 100 divided by 25 is 4. You guys are so stinking smart. Okay, awesome. I'm going to do one more, and then I'm going to let you practice a few, and then we're moving on. So one more. Sorry. Yes.
Can you like how I learned it as that.
Uh-huh.
Divide it by that one.
Yeah, that'd be the same thing. So you were able to see, and that's what I'm going to do in my next one. You're absolutely right. Justin made a good point. He saw that, you know what? We did a lot of extra steps, actually. If we would have just multiplied 10, would we have achieved our goal from the beginning? Would have X been alone? Yes. So that's what I'll do in the next example. Thank you, Justin, for pointing that out. Absolutely correct. So looking at this one, we have 3 over 5 is equal to X over 25. The first thing I'm going to ask you, can you really, truly, are you sure you can use cross multiplication for this one?
Yeah.
Yes. Is there a fraction on one side?
Yeah.
Is there a fraction on the other side?
Yes.
Is it just a fraction?
Yes.
Yeah, so we're good. Let's cross multiply. Now looking at this, we're trying to solve for X. Really, we're trying to get X alone. So let's just look at it and say, well, we need to get rid of 25, right? We need to get rid of 25. So let's go ahead and get rid of 25. But how do you get rid of 25? It's on the bottom being divided.
Times by 25.
Good. Multiply both sides by 25. So I'm going to multiply both sides by 25. Multiply both sides by 25. And now over here on the right, what happens?
Cancel.
Those divide out. 25 divided by 25. Now over here on the left, I have 25 times 3. Oh, okay, I need to say one more thing before we simplify the left. When you're multiplying fractions, you multiply straight across. Recall that. You learned that back in like grade school, but we forget things. When you're multiplying fractions, you multiply straight across. So if we have just a 25, technically, it's really 25 divided by 1. Because what is 25 divided by 1? Just 25. So if you need to write that 1 in there, that will help you. Some of you that still have a hard time multiplying fractions. Now you multiply straight across. What's 25 times 3? 75. What's 1 times 5? 5, which is equal to X. Now this is where Justin said, okay, well we've achieved our goal in one step. Why not just do it in the first step? So this was awesome. So now we've achieved our goal. X is all by itself. So let's just simplify this. 75 divided by 5. 15 is equal to X. X is equal to 15. Same thing. And we're done.
Can't you like go from the start and just do 25 divided by 3 and then divide it by 5? And then
Yeah,
divide it by 20
3 times 25 is 3.
And that is that's exactly what we did. I just showed all my work for everybody, but that's essentially actually what we did. So yeah, absolutely, yeah, you can go at your own pace for sure. So do these 2 problems quickly. I'll come around and check them so I know you know how to cross multiply, and then we'll move on to the new lesson. Some of you can kind of skip steps, many of you can't, and that's fine. If you can't, show your work, and that's great. These 2 problems up here, you'll just do on your own. You're so smart. All right, moving on to the new lesson. Okay, so right now is where you would take notes. So remember, you should have your notebook ready to take notes right now. I don't want you to get your notebooks ready. You don't need to take notes on this. We learned this yesterday. I just want you to look up here. But you can title your notes 1.1.2 today. 1.1.2. And on this first slide right here, this first thing, I don't want you taking notes on. I want you watching. So yesterday we learned about the zero power rule, the zero property of exponents. And we learned, now this is super important, we learned that any base, no matter what it is, any base raised to the 0 power is equal to 1. You know what? We even learned that cupcake to the 0 power is equal to 1. So we learned that 25 to the 0 power is equal to 1. That's a base raised to the 0 power. It's equal to 1. What's 2,000 to the 0 power? We learned it's equal to 1. Any base to the 0 power is equal to 1. X to the 0 power is equal to 1. And we learned that 2x, since this was in parentheses, raised to the 0 power was equal to 1. Because anything to the 0 power was equal to 1. So I'm just going to have us verbally, I don't want you to write these down. We already did these examples, some similar. Let's simplify these. What's 2x to the 0 power? Whoa, do I have black on my face? Look at I don't know what happened to my fingers, but
Here, just a bit, right?
a mustache, maybe I'll draw one.
No, let's just try.
Okay, I'm glad it's not too bad, as long as it's not too bad. Okay, 2 times x to the 0 power, what is it? 2 times what?
1.
2 times 1, very good. 2 times 1, which is 2. Does everybody understand how x to the 0 power becomes 1?
Yep.
Okay. How about 3 times ab to the 0 power? Is a and b raised to the 0 power?
Yes.
And anything to the 0 power is equal to 1. So really, this whole part becomes a 1. 3 times 1 is
3.
3. Is everybody okay with that?
Yep.
Next one. It looks a little bit scary, but we're not scared. 4 times x to the 0 plus 5y to the 0.
4.
What does this become?
4 times
4 times 1. Good. So this becomes 1 right there. So 4 times 1 is 4 plus. Oh, yay. What is it? Anything to the 0 power is equal to 1, so that whole thing became 1. So we have plus 1, so our final answer would have been 5. Is that a good review from yesterday?
Yep.
Okay. We're learning a new property today. It's called the product property. This is where I would start taking notes for sure. The product property. So this is what I would write down is this part right here. In fact, I'm going to highlight it and make it big for you. So what the product property says, if you multiply the exact same base, then you will add the exponents. That's what I want you to write down is this. If you're multiplying the same exact base, then you will add the exponents. You don't need to write down the words. This rule is saying that. But I'm going to say it one more time as you write down this part of the rule. When you're multiplying the exact same base, you are going to add the exponents. Very important. Add the exponents. So notice looking at this. I have base A raised to the n power times by base A raised to the n power. A and A are the same base. I'm multiplying the same base, so the rule says I'm going to add those exponents up. N plus n. Does that make sense? Okay, we got to start practicing a few. We'll start practicing a few. All right. Does everybody have that rule written down?
Yes.
First example. We're going to start very, very basic. A squared times a to the third. The first thing you need to check, do I have the same base?
Yes.
And I'm multiplying the same base, so I do what? Add the exponent. So this is going to be equal to a to the
Fifth.
2 plus 3. I'm just going to show my work on this one. So that's equal to a to the 5th. So really, if you think about it, guys, we're taking this thing that has a bunch of a bunch of things. So they have a bunch of things. We're taking it and I'm writing it with the magic pen. No wonder. So you're taking this big thing, you're crunching it into 1 using properties of exponents. So we did 2 plus 3, which is a to the 5th. Does that make sense? We're taking it, crunching it using properties of exponents. Okay, now I'm going to explain to you. Don't take notes on the but why part, but watch how cool this is. This will be like, because you're like, well, it feels more natural for me when you multiply to multiply. Well, you guys, this is why that doesn't work. I'm going to show you why this works, and this is going to be like caveman style, how the cavemen would have looked at it, and it'll be like, okay, that makes total sense of why we do that. So I just want you watching. So if we want to be basic, go back to caveman times. A squared is a times a. Is that true?
Yes.
So we have a times a, and we're going to multiply it to a cubed. Well, a cubed in caveman times, just a times a times a. So looking at that, how many a's is that? 5. So that's why if we squish it back together, that's a to the 5th. Does that make sense?
Yes.
Yeah.
Okay, it's kind of cool, right? Okay, awesome. Let's do another one. X to the 5th times x to the 3rd times x squared. Are we multiplying the same exact base?
Yes.
Yes.
Okay, so what do we do with the exponents?
You add.
Add them. So we're taking this, we want to scrunch it into 1, and we can do that by adding the exponents. So 5 plus 3 plus 2. So that's going to simplify to be x to the
10.
Thank you. Any questions at all? Okay. Number 3, don't write that one down. I'm going to ask you, can we simplify number 3?
Yes.
Look at it. The rule says if you have the exact same base, and you're multiplying them, then you can add the exponents. Do we have the same base?
No.
No, you can't combine those. That's as simplified as it gets. All right. Okay, this is one that just throws secondary 2 students for a loop. So we've got to talk about it. We've got to talk about it right now, and then we should be good. So we have x squared times x. X squared times x. Are we multiplying the same base?
Yes.
So we add the exponents. Well, yikes! There's no exponent there, so it must be 0. Or
It's 1.
it's 1. Good, it's not 0. If there's not an exponent there, it goes without being said that there's a 1 there. So if you have to write those in, do. Because most people forget, and they don't count that x, and then they get it wrong. Okay, so now we can go ahead and condense this into 1. We're multiplying the same base, so we'll add the exponents, so we'll get x cubed. I skipped steps on that one, but are you comfortable at this point for me to be able to do that?
Yeah.
Awesome. We're getting smarter and smarter every day. All right, let's get to some juicier stuff. Okay, so we have 2a to the 5th times 3a to the 4th. 2a to the 5th times 3a to the 4th.
Times 2 times 3.
Yes, you're absolutely correct. Okay, so I have a quick question for you. You're absolutely correct. You know how to do this. Is the 2 connected to the a to the 5th?
No.
No, it's just multiplication, right? So we know that we can rewrite this as 2 times a to the 5th times, is 3 connected to a to the 4th?
No.
3 times a to the 4th. And then is 3 times 2, so this is a good question, is 3 times 2 equal to 6?
Yes.
Yeah.
Well, what if I reorder that and say 2 times 3? Does that change the answer?
No.
Oh, wait, so those are both equal to 6 even though I reordered those multiplication numbers? So can we reorder things when multiplying and get the same answer? Yeah, that was just a prime example. So let's reorder this. So what I'm going to do, guys, is put the numbers by each other. So 2 times 3. I'm going to put the bases, the like bases by each other. So times a to the 5th times a to the 4th. Does everybody see how same thing, different order? That's all good. Now let's go ahead and simplify. Now this is what I'm going to ask you. The song, I have a song that I sing for all the properties of exponents, but we've only learned 2, so we won't learn the song till the end. But when you multiply the same base, you add the exponents. Does that hold true for a 3 and 2?
No. Yeah.
Are those the same base?
Yes.
Yes. Well, no.
Is 3 and 2 exactly the same base?
No.
So do we add their exponents?
No.
Do we add 2 plus 3?
No.
No, multiplication doesn't change. 2 times 3 is 2 times 3. We're not, properties of exponents don't apply here. Do you understand the difference? What's 2 times 3?
6.
6. Now do the properties of exponents apply?
Yes.
Okay, good. When you multiply the same base, you add the exponents. So 5 plus 4 is
9.
9. This would be our final answer. Questions? Okay, let's do another one. A little bit harder maybe. 3x times 3x to the 4th. Do you want to try it by yourself? Ready, set, go. Try it by yourself. Be patient with me though. Stay with me, guys. Do what I ask because I promise you you're going to get through the entire worksheet today and we're going to have a fun activity at the end. So I want you to stay with me and stay focused so that we can have a strong foundation for this property of exponents. Like, I'm seeing people with the answer 9x to the 4th, and I'm seeing people with 9x to the 5th. So let's go through it really quick. We know we can reorder this in any order. So I'm going to put my numbers by each other. 3 times 3. Then I'm going to put my x's by each other. So x times x to the 4th. Now you'll go through and simplify. 3 times 3 is 9. Now right here we have x times x to the 4th. I saw a lot of x to the 4th in your final answer. What is my exponent on x though? 1. So 1 plus 4 is
5.
x to the 5th. Now remember, we only are adding the exponents because we were multiplying the same base. So they have to be being multiplied for this to work. Do you understand that?
Yes.
I should be more clear. Okay, work on. Okay, this is the last one. This is one of the most common errors I ever see in students. So just quickly, last example, then I'll let you work for a second. 2 squared times 2 to the 100th power. The question I have for you, so given 2 squared times 2 to the 100th power, do we have the same base?
Yes.
Yes.
And we're multiplying the same base, so what do we do with the exponents?
Add that.
We add. Now this is what I call double dipping. This is what I see people do. They multiply 2 and 2, so they get 4. This is incorrect, so don't write it down. They go 2 times 2 is 4, and then I add the exponents. That is not true, guys. The base stays the same. The rules go. If you have the exact same base, then you're multiplying it, you add the exponents. Does that make sense? When we had x to the second and x to the 100, we didn't add those x's and do the exponents, we just did the exponents. So the base would stay the same, and we would have 2 plus 100, which is 102. This would be correct. Does everybody get the difference? Be careful. Okay, good. Do problems 1 through 5 quickly, not quickly. Do it at your own pace, but we will get through this worksheet today, so you're all good. But I'm going to be coming around checking. Check with your neighbor. This is the appropriate time. You absolutely can talk during this time. In fact, I encourage you to talk to your neighbor and ask for help or whatever. Or just even check your answers. Okay, it's good. I was going to say it's not recording, but it is. Okay, moving on. All right, so what if we have more than one base? Well, that's no problem. No problem. Properties of exponents never change. If you multiply the same base, you will add the exponents. So now we're going to get a little bit deeper. We're going to be seeing things with more than one base. But you know what? It's fine. Those rules still apply. So here, it brings me to my first example here. I'm asking us to simplify x squared, y squared times x cubed, y to the fifth. One more time, x squared, y squared times x cubed, y to the fifth. So as you get that down, think about it. Think about it for a second. Is x squared and y squared connected? And is x cubed, y to the fifth connected?
No.
You're right when you say no. I want you to tell me why you think no.
Because it's like having the number next to it.
Okay, that's a good point. So he was saying it's just like having the 2 in front. It wouldn't be connected, so why in the heck are these two connected? And I heard somebody else say, well, these are just being multiplied. So really, we can reorder this in any order. This is just multiplication. So we can split this up. This is really just the same thing as putting a multiplication in all of these things. And then reordering it. So I'm going to have x squared. I'm reordering it, and I'm going to cross it out as I go so I don't leave anything behind. And then I have x cubed. And then I have a y squared. I'm just reordering this in a different order. And then I have times y to the fifth. Now, when you multiply the same base, you add the exponents. So let's go ahead and focus on the same bases. So we have x squared times x to the third. When you multiply the same base, you add the exponents. So we get x to the fifth. And then right here, we also have the same base. So we have y squared times y to the fifth. We're going to add y to the what?
7.
7. That would be our final answer. So it's not any more difficult. Don't let it be. You know what you're doing. So let's do just a couple more because it does some. I saw a lot of people. I skipped a few examples because I thought they were understanding it, and then I was walking around and everybody was making the mistakes. And I was like kicking myself for skipping. So we're going to just do these. I promise you'll finish. All right, negative 2x times 3x to the fourth, y squared. Negative 2x times 3x to the fourth, y squared. Now, we know none of these things are connected. It's just a bunch of multiplication. Let's reorder it in a different order. So I'm going to rewrite it as negative 2 times 3. I'm going to cross them out as I go. Then I have x's, so times x to the fourth. Just took care of those two guys. And then I have times y squared. Questions? Simplifying piece by piece. Negative 2 times 3, do I add those together?
No.
No, those are numbers. We multiply the numbers. Negative 2 times 3.
Negative 6.
Negative 6. Now right here with x's, we're multiplying the same base, so what do we do with the exponents?
You add.
Add, so we get x to the fourth, right? There's not an exponent, so we don't add anything.
Wrong.
Wrong, it's what?
It's x to the 5th.
X to the fifth. There's technically a 1 there, so if we added those up, we'd get x to the fifth. Oh, y squared, nothing to combine it with, so we have a y squared. Okay, questions? Okay, how are you feeling about this? Great. This is the last one that I'm going to let you work. Promise. Last one that I'm going to let you work for a while. And then I'll bring it back to me in a minute. We have -4. This is the one I skipped. And then everybody was getting them wrong. So I have to talk about it. -4, x to the 0, y, times -2, x cubed, y. Yay. This is the trickiest one we've seen yet. But we know properties of exponents. We know properties of exponents. And we'll use them. And we're multiplying all these things. And we know they're not connected. So I'm going to reorder it. -4 times -2. I just took care of those. Then we have x to the 0 times x to the 3rd. And then I have a y times a y. Does everybody see how I just reordered it? Let's simplify it. What's -4 times -2?
8.
Good. I heard +8, which is correct. Negative times a negative. And then, let's look here. Are we multiplying the same base?
Yes.
So we add the exponents. In this case, it is 0 plus 3, which is
3.
3. So we have x to the 3rd. And then in this case, what are we going to have?
Y to the second.
Y to the 2nd. You added the 2 1s that were there. Even though they weren't there, they technically were there. So we have y squared. Now, one last thing. Let's pretend like I changed the problem. That's the final answer. Any questions? This is what I didn't specify. Let's say that we had this as a final answer. Let's say I would have had this instead. Let's say that this would have been y to the -1. So down here it would have been y to the -1. And what would we get when we added them up?
0.
We get y to the 0 in our final answer. Now, what is anything to the 0 power equal to?
1.
Is it the power equal to 1 or the whole thing?
The whole thing.
Oh, so really that just becomes a 1, so it just goes away. Does that make sense?
Yeah.
So our answer would have been, in that case, in that example, I just changed it to just 8x cubed. Okay, are we all okay with that? Okay, awesome. Work on these problems. 6 through 10. Make sure you're getting them right. For you. If I have negative, this will really help make sense to some people for some issues you're having. If I have -2x squared, for example, and then I multiply that to -x to the 3rd, I'm going to ask you a question. Is -2 connected to x squared?
No.
No. Is this negative then connected to x cubed? Is it?
No.
-2 wasn't, so why would this negative be?
No, it's not.
So really, technically, what number do we have out front here?
1.
A 1. So really, technically, we have -1 out front. Now, once again, -2 is not connected to x squared, neither is -1. So that's just like having a number. Does that make sense?
Yes.
So go back and check your number 8 and make sure you got it correct. Even if you're not finished, you need to be paying attention. We're going to talk about something a little bit further here. You can always go back to those as homework or at the end. You'll have time to finish. Okay? You'll have time. Okay, so now I'm going to talk about negative exponents. Some people say, well, what about negative exponents? But I'm telling you right now, properties of exponents do not change no matter what. They're the exact same no matter what the exponent looks like. As long as you have the same base and you're multiplying the same base, you'll add the exponents, no matter what the exponent looks like. So let's look at this first example. This one you don't necessarily need to write down because it's a very simple example and you're getting how this works. I'd rather you just watch this one. We have the same base. We're multiplying the same base and so we add the exponents. Even though we have a -2, the rules don't change. You add the exponents. So to condense this into 1, we're going to add those exponents. So we have x to the -2 plus 3. Any questions on that? Now, we have a lot of errors. We're going to get better, I'm hoping, soon here. But a lot of people are making a lot of errors with adding and subtracting negative and positive and negatives and negatives. And so be really careful. Just as long as you're cautious, you'll be okay. What's -2 plus 3? 1. And we're way more advanced than that. That wouldn't be completely simplified. That's right. But we would write our final answer as just x. Because we know that x is the same thing as x to the 1st. Does that make sense? Okay, let's go a little bit harder. Okay, x to the negative 5th, y squared, times x to the 7th, times y to the negative 1. Okay, we do have negative exponents, but the rules don't change. If you multiply the same base, you add the exponents. So I'm going to reorder this in a different order because we know we can. We have x to the negative 5th times x to the 7th times y to the 2nd times y to the negative 1. I just reordered it. Now the rules don't change. If you multiply the same base, you add the exponents. So we're going to get x to the 2nd, and then we're going to get y to the 1st. And my answer, since I'm in secondary 2 now, I'm a little bit above that. I'm going to write the answer in the most simplified form, which would be x squared y. Just simply y, because y to the 1st is just y. Okay, I'm going to push you to, really simplify your answers. Now, make sure, especially if you were to come out with like a y to the 0, don't leave your answer like that. You know that goes away and becomes a 1. And don't write the 1, it just goes away because anything times 1 is just itself. Okay, something like this, negative 2 times a to the negative 3 times 4 times a to the negative 7. You would just reorder it. Negative 2 times 4 times a to the negative 3 times a to the negative 7. This is the last one, I think, and then I'll let you finish up the worksheet, but I need you to watch this one. Does everybody understand how I just reordered that?
Yes.
We're all okay with that. What's negative 2 times 4? Negative 8. I'm so glad you didn't add those things. Those rules only work if you have the same base, and you're adding the exponents, not the numbers. All right, we just multiply those. Negative 8. a to the negative 3 times a to the negative 7. When you multiply, you add the exponents if you're multiplying the same base. So we have a to the, now be careful. Be careful. What's negative 3 minus 7? Negative 10. So we have a to the negative 10. So if you have to think about it, guys, I'm in debt $3. I subtract $3 more. I'm now in debt $10. Does that make sense, everybody? We're all okay? Okay. Finish up the front of the worksheet. Finish up the front of the worksheet. And I didn't give you the back because we're going to do that next time. But I'm going to give you a certain amount of time. Finish it up, get it right, and then we're going to have a competition, and the winning group's going to get a treat. So in a minute, when we've finished, we're going to have a little friendly competition. Okay? So finish those up and practice. And I'm going to come around and make sure you're getting them right. Ask your neighbor for help. Check with your neighbor. You can be talking at this time.
Oh.